Okay, so this doesn't make sense economically at all, and it's probably not a very safe thing to do. So I wouldn't listen to me. But what I have is a bunch of this Christmas garland. These burn out after a season or two. They're incandescent, and I'm just the kind of person that, first of all, I like to screw around with stuff, and second, I hate to throw something like this away when the only thing wrong with it is light bulbs burned out. At the same time, I don't feel like buying a bunch of these mini bulbs. What happens with them is one goes out and they have a wrap around them so that they still pass current when one burns out, but then the others run at a higher voltage, and so if you're not on top of things and change out the bulbs right away, they end up all burning out in sequence because, I mean, first of all, they're all about the same age, but also they're, as they go higher in voltage, it puts more stress on them and they burn out. So I figure, why buy a bunch of new incandescents when I can go online and buy, 500 LEDs for, I don't know, $10 or something like that. These are a no-name brand. They're probably junk, but it doesn't matter. It's a Christmas light, right? And there's a big sack of them. Incidentally, LEDs will do the same thing. They'll fail short, and they will pass more current to each one. So if you're not careful with the LEDs, they will have a cascade failure as well. I don't care if they say long life or or whatever. Now, there are already videos on how to do this, convert to LED. Big Clive has some really good ones. However, he does it with 220 volts, and 110 is just a little bit different. I shouldn't say 110, and I shouldn't say 220. It's 120 volts. So 120 volts is a little bit different. This is a 50 string, or a 50 light string. And when you add up the forward voltages of the LEDs, you barely have enough voltage to light the whole string. And you don't really have to worry about current limiting with a resistor too much. I still put one in line. This wire is not great, so it is a big resistor, right? But in any case, I still put a resistor in line. More Chinese stuff. These are big. I think they were sold as 3 watt. I wouldn't trust them with more than like a watt or so. But in any case, it's a big fat resistor. It's gonna, most of the time, you'll have a couple of milliamps trickling through here. So it's way more than up to the task. I suppose when all these go, if all of the LEDs go short, then it'll see some serious current, and I guess it becomes a fuse. I'm not going to remove the fuses, so I don't. There's fuses in the plug end, and so I don't know what they're rated at. 3 amps, it says. It's a lot. 3 amps is more than enough to smoke this guy, but anyway, like I said, this isn't like a safe thing to do. So hopefully I only set fire to my landscaping. I'll show you in a bit. I've got some more bad ideas coming. Okay, so anyway, just to functionally do this, I've kind of got it down to a science now. I've done a couple of these strings. The first thing I do is I pick, it's kind of arbitrary, but I pick one lead to be the negative and the other to be the positive. In this case, I had to pull this guy off and look in here, and I can see where the wire comes in, and so these two are actually joined together. This one's separate. So because this goes up the chain, I decided to call that negative, and this incoming one is positive. So I'm kind of going to do this in like an assembly line fashion. The first thing that I need to do is just go down with a Sharpie, and I'm going to mark the negative side of each of these. Oops. You can see I had some trial and error problems here, but so I'm going to go down, and I already started marking these because it's kind of a boring process, so I'm not going to put you through that, but it's important to, especially with these things lost in the garland, kind of twist them around, make sure you got the right side, and then just go and mark them all. I've already got a good start. I suggest putting on like a YouTube video or something to keep you occupied, and just do this like you're knitting. It's a nice tedious task. It's not something that's particularly fun. So anyway, I'll cut back after I've completed this. Okay, I'm down to just the last few here, and I wanted to make sure I show where I'm marking these. It doesn't really matter on the body too much, but up here where the removable part is the important part to mark, because the LEDs are obviously sensitive to polarity, and these are reversible sockets. So it's important to mark it. I mean, you'll survive if you don't, but it won't be fun trying to figure out the polarity of the LEDs after the fact. So that's why I'm being careful to make sure that I get the polarity right. So that should be the last one. The next part is pretty straightforward. I'm just going to take all of the bulbs out and take them out of their little socket, and I throw these away, but I suppose you could check them and save them for as spares. They probably don't have a whole lot of life left in them if the string went out, because the other bulbs, there's several that are burnt out in here, so chances are these are not too long, but yeah, I'm not here to tell you what to do. So let me take these bulbs out and denude the bases, and then I'll restart. Okay, so there is my big fat pile of 50 denuded bases. Now, next, obviously, we're going to put the LEDs in there. Okay, these are not the ideal LED. I don't think you want to make a bunch of little spotlights. So the idea is to use a shape LED that spreads the light out a little bit. And these flat top ones do a pretty good job. Even better for Christmas lights are the concave ones. So I got these because they were available quickly, and I bought them before I really knew what I wanted existed. The main problem is these sockets are almost exactly 5 millimeters. They're probably 5 millimeters, and the LED fits in there just wonderfully. However, it's a short LED, so and there's this I think the technical term is actually fringe. There's a fringe on the LED. At least that's what the Chinese sites use to describe it. The little, if I try, can it focus? There you go. So there's that little ridge on the LED that normally prevents it from poking all the way through a hole. You don't actually want that in this case. You want you want it without the fringe. Until I found the keyword fringe, it was hard to find online the ones that didn't have a fringe, and that's why I ended up with these. I'm using them up. I have, like I said, 500 of them. So this next step is unnecessary if you have the fringeless ones. It's tedious and it's messy, but I just go around with my set of side cutters and I just clip off the fringe. Ridiculous, yes, but I noticed that the you don't have to do it that way. You could let it sit on top. So the shorter one is obviously negative. That goes where we marked negative. You could just have it sit on top, and you could fold the legs over, and it would work. I don't know. It feels tenuous to me. like I don't know. Like one of these is going to rust out, and then it's going to come off, and then there's just going to be this potentially high voltage with reference to ground thing sticking out. I mean, I know that can happen anyway, but it's just not. It's not what I'm looking for. Also, incidentally, if you bend them like this, and you need to reposition, it's pretty much trash at that point. You bend this a few times, and the leg just falls off. So there's no point in trying to use this thing. It's in the trash. Okay, so here's the one where I chopped off the fringe. And same thing, short, negative. And it just pokes through. You could push it all the way in. I don't think that's what we're looking to do. So I tend to poke it a little bit down in there, but not crazy. And then once it's down in there, I just fold it over. I don't worry too much about how high it is. It looks good either way. And now I do this like in an assembly line kind of fashion. So I count out 50 of these, which I'll spare you. I count out 50 of these. I trim off all the fringes. I then fold them in like this, and then I come back with the side cutters and clip each one. If I were Big Clive, I'd tell you a little story, complain about the local electrical certification authorities, things like that. I'm not that interesting. So instead, I'm just going to do this one. Well, now this, I guess is the second one. I'll do the second one, and then I'll cut to when they're all done. And I bet you can guess what the next step is, because again, it's pretty straightforward. We'll get into the electrical part of it afterward. Yeah, I said I was going to do the whole thing, so here we go. All right, 2 down, 48 to go. The next step is pretty straightforward. These on the end are different sockets than the ones in the middle, but pretty straightforward. You're lining up the mark you made on here with what you marked as the negative side, although the negative side is kind of self-evident. Now you'll notice they're a little hard to push in because the new the LED leads are way thicker than the little thin copper wire that was there before. Just to save my fingers, because after 50 of these, your fingers start to hurt. I generally just take a pair of, a pair of pliers and push them down like that. It's just far easier on your hands. And once again, you only need to see me do a few of these to get the idea. So again, you turn on a YouTube video and get to your knitting. Just turn the brain off and pop LEDs into your socket. It's a good way to kind of get a feel for what it must be like to work in a factory that makes these kind of things. I don't know. Maybe it's a machine. I have a feeling it's not a machine. So I'll come back when this is done. All right. So at this point, all of the bulbs are in, and so it's currently still set up for line voltage for AC. There's a way to put the okay. So this is a rectifier. Rectifier changes AC to DC, basically. It's still very. It's not really DC. It's still got. It's chopping the waveforms. It's flipping everything to across the zero axis, but you can smooth that out with a capacitor, and then you'd have something like real DC. But in any case, we're just going to consider it DC, and the reason that I'm doing that is it is less flickery than if you don't do it. If I really was worried about flicker, I'd put a capacitor in line too. But I'm happy with what it looks like when it's full bridge rectified. The LEDs themselves are diodes, and this is nothing but 4 diodes in a package. So you can use the LEDs themselves as the rectifier. The problem with that is they'll only light on half the cycle. They'll block on the other half of the cycle. So you get a lot more flickering than you do if you full bridge rectify the signal. So what I'm going to do is just snip this. Let's get. I'm just going to snip this. And then I'm going to solder the incoming leads to the. If you look on here, it's marked, but otherwise you can also look at the data sheet. By the way, this is a piece of crap rectifier. Way overspec'd for this. It's probably for 8 or 10 amps. I picked it up cheaply. It's just a Chinese rectifier. I also have a part number for a proper, still way oversized, but a proper one from, I don't know, Taiwan Semiconductor or something. So anyway, it doesn't really matter. For this application, it's going to be rectifying milliamps, and it's spec'd for 10 amps. So it'll run nice and cool. I don't have to worry about it overheating. And same thing with this resistor. Honestly, you don't. I don't think you really need a resistor in this circuit. The wires are so thin, and there's such a long length of it that let's take a look. It's a tiny little wire. It's fine for this application, but it's like a resistor. But I'm going to put it in. There might be something with. listen, I am a mechanical engineer, not an electrical engineer. So when you start talking about things like inrush current, and fine. Here's a resistor. It's supposedly a 3 watt. It's not. It's a, well, it might be. I don't know. It doesn't need to handle anywhere near a watt, so it's fine. Oversized. And then adding to the insanity a little bit here, I used to just I would take 4 discrete diodes and make my own bridge rectifier, and then I would kind of shrink wrap everything in line, and it worked fine. But I have a squirrel, not as a pet, as a kind of a local wildlife that loves the taste of shrink wrap. So I like to draw things in CAD, and I have a 3D printer, so why not? This was, I don't know, like 25 grams of filament or something. I made a little rectifier holder for the rectifier. The resistor sits in there, and then the wires. It's nice. It adds strain relief to the wires, and it is squirrel proof. I've experimented with different ways of sealing this. I used super glue and it worked fine. I used the heat gun just on the edge to melt the PLA, and that also works fine. I think that's the method I'm going to use. And then I put the whole thing in shrink wrap when I'm done. It goes without saying, this is stupid. This is flammable. You really should use a flame, what do you call it? Not flame retardant, but a material that does not support a flame. They do sell that. It's maybe twice as expensive. I don't have any. So yeah, it's stupid. Putting it in the shrink wrap should help. The shrink wrap itself is flame. It does not support a flame, and this won't be able to get any oxygen if it's inside the shrink wrap. And yeah, I'm gonna burn something down, but in any case, I'll have fun doing it. So yeah, don't do any of this. Okay, so time to fire up the soldering iron, and while that's heating up, I'll strip the wires. We can do a thing, so just to prove that I don't really need a resistor in this circuit, what I'll do is I won't make the last connection, and we'll run a meter across in order to measure the current. The LEDs, I don't know what the spec of these are. It doesn't really matter. They're typically, yeah, it does have it actually, 20 milliamps. That's typical for an LED in this kind of package. So what I'll do is that's interesting. It has so the LEDs are marked here as having 3 to 3.2 volts forward voltage drop. I have a tester. I could have sworn I measured these as 2 point something. Let's see. 2.72. That makes a big difference, because you need enough voltage to make the LEDs light up, and if the output of the rectifier from house voltage is not high enough, the LEDs won't light. But anyway, I'm pretty sure the lower number that I have is the right one. Let me make sure. sure I'm off camera here. There we are. That's better. So, just going to tin the no, the camera's not in the way at all. I could turn on the fume extractor, but then you'll hear nothing but fume extractor. So I'll just breathe the toxic smoke. Okay, so this is the input. So this is going to go to the middle pair of yeah, I'm going to do this upside down because that's the way I have the holder designed. I will link the Thingiverse drawing. I designed it in OnCAD, which is just a free CAD, parametric CAD tool. Like I said, I'm a mechanical engineer, so that's more my thing than soldering. Try to be gentle with my... just trying to get that, knock down the whiskers. I should have put some flux on here. That's okay. Okay, I'm going to trim down this resistor just to shorten the... so I'm not going to put this in yet. What I'm going to do is... So here I have already marked what I'm considering negative. Let's make sure that matches. I have a big plus on there now, so... Yes, this is plus. Yeah, okay. I seem to have it correctly... labeled, so plus, minus. Same thing, just going to tin these up. Little smoke. Oh, you know what? These legs need to be 2 different lengths to accommodate the... one's going to have the resistor on it, so it needs to be, you know, yeah, much shorter. So we'll just... It's going to be the positive one that gets clipped. Let's try to get it about right. Okay... I originally drew this with providing for 2 resistors just to spread the load across 2, but because of the at the time I only had these 10 ohm resistors. So I just put one. It's dropping so little current. I didn't really see the need to split it up. I since have bought smaller value resistors, but not really necessary. Okay, I'm going to leave this out for now. I'm going to hook up the negative. Okay, getting a little hot, Ray, getting a little hot. And, okay. So, let me just make sure this stuff looks nice and clean. Oh. Oh, that hurts. All right, let me just... Good God. Oh, man. Okay. I'm just going to cut my losses here and trim that off. Yeah. It's better. Ping. Here we go. I said this is the negative. Yep. Okay, that looks better. And I think we're on there. Whew. Yes, nice. Okay, so now I'm going to do the kind of sketchy thing here, and I'm going to hook my meter up in between. Amps. Okay. This is where the autopsy is unnecessary because they have video of me killing myself. Let's see. So comes in, goes out. All right. And now the sketchy part. We're going to look at the... I also have a, one of these kilowatt meters attached. So that'll tell me the I don't want the power factor. I want the wattage. There we go. Okay, that did a whole lot of nothing. Except scare me a little bit because it's coming at me. So I probably have a problem in the circuit here. Let me see if I probably have a LED backwards or something. Sketchy. Okay. Let me look at this. They are not even flickering. Usually if you have one backwards, they'll still kind of flicker a little bit. Because it reverse conducts enough. But this is giving me nothing. It is not even passing any current. Yeah, I don't see any activity at all. So it's good I have the meter out because I've got some debugging to do. So I wish I could say that this never happens, but it happens. Okay, so suspecting that I had one of them backwards, I turned out the lights, and you can see they're dimming very glowly. They're glowing very dimly. So that means one of them is probably reversed. And so it's just allowing a little bit, a few microamps of current through. I found my dark one dark. So this is live, and I'm holding the phone. Let me mark the dark one, and then I'll come back and with the lights on, and we'll reverse it. Okay, so that's my dark one. I have to be a little careful because that's my circuit there. So I'm just going to pop this out. One-handed for the win. And we will reverse it. I apparently marked it wrong. You can see the direction. This should be the direction down the line. So the negative should be on the back side. And what do you know? The negative mark is on the front side. Tisk, tisk. Oh my God. Yay, look at that. So, I don't have it in very well, but you can see, you get the idea. Okay, so I'm going to seat that properly, and then we'll go back up and we'll measure the current. But you can see the kilowatt is saying 2, what is that? What mode am I in there? Watts. 2 watts for the whole string, 50 lights. That's a 20 milliamps on the wall side. We'll measure across. 20 is a little on the high side, but I think it's actually lower going through on the DC side. So we'll, because there's a power factor here, right? Yeah, 0.83. We'll measure it with the meter on the DC side. We're back to my super sketchy setup here. Hopefully I'm not touching anything AC. We're gonna plug it in. They came on, and yeah, you can see from the meter it's 12 milliamps. That's running through the 10 ohm resistor. So I'm not really sure that's necessary, but that's all that's running through that thing. So there's not really any problem with heat in this circuit, at least not in its normal state. You can, of course, if a bunch of these go short, then we have a problem. But hopefully I'll start noticing if they start going dark. And, quite a few of them could go dark before the current gets over the spec for them. So I think at 12 milliamps they'll last a very long time. All right. So now I'm done with the suspect stuff, the sketchy. Let's turn some lights back on here. I'm done with the part where, it's only 110. Why do I always say that? I think a long time ago the U.S. standard was 110, and so stuff is labeled 110, and for some reason I just grew up kind of saying 110. I know it's 120. I just measured it. It was 123 here in the house. Okay, so we're just gonna tack this guy on here. Yeah. Okay, so then this is the part that's a little strange, over-engineered, and whatever. It's fun. Makes a neat thing. So one thing I should mention is I haven't cut the end off of this string. It's meant to be chained together. So now I've rectified the current, or the help me out here. Rectify the electricity. So if you plug something into this end, it has interesting implications. Another string, I wouldn't need another rectifier. I could chain them together, and in fact, I have a set of very deep violet lights that I have never seen in the stores. I like those UV LEDs. I like to put them in the bushes and stuff. It makes a neat look, but they're not very bright. But the so what I do is I put a different end on them, a non-standard end, to kind of make it clear that they're that it's not that you shouldn't plug your vacuum cleaner or something into this. Yeah, so I think I'm just going to leave the plug on there. If you did plug another string in, it would just be a little bit dimmer because it'd be exactly the same as this string. But if it has another rectifier on it, it'd just be a little bit dimmer because you'd get some voltage drop from the second set of diodes. But it would still work. So, yeah, I don't know that I need to really fix anything. Okay, so next step is I'm ready to seal this baby up. So I have just been putting it into this clamp, like so, giving it a little squeeze, not getting carried away. And then I'm using this heat gun, and it's going to mess up my pretty little case because it melts the PLA as it comes up to temperature. But I think it's so much faster than the super glue. And it's just going in shrink wrap anyway, so the fact that it kind of warps I'd like to think that it's waterproofing it a little bit, but I don't think that's true. And then while I'm here, I'll just take this edge. I'll flip it over to the other side. Make sure it's not gooey. See, it's reasonably together. I don't know. And then I'm going to do the same thing to the other side. Make sure the wires are good. The wires on these cheap lights are a little... They seem to melt from the heat too, so I got to be careful when I get over there. I have the heat gun set to 250. I figure that's pretty good for hot air. The printer was set to 215 to print this PLA, so it's PLA plus. I mean, if you can buy two products and one's called Plus, how do you buy the one that's not Plus? How would you sleep at night knowing that you'd bought the non-Plus product? I suppose that doesn't work with clothing sizes, but... Okay, and then I'm just gonna... Probably a bad idea, but this project has so many bad ideas. Why stop now? You can see it discoloring a little bit. Nothing. Okay. Let's call it done. And just for giggles. Yeah, I mean, it's together. Who knew? So now I'm going to just plug it in one more time and make sure it's still working. And behold, bright Christmas lights. Excellent. All right. I'm going to change the nozzle on that because it's too narrow. It's like a surface mount nozzle. I'm going to put a big fat one on there to shrink the heat tubing. I'll be right back. All right, and this is the last little bit. I'm just going to take the heat shrink and shrink it. Heat shrink is always so much fun. It's like the real promise of shrinky dinks realized. I would say I use this hot air station far more for heat shrink than for SMD components. And you can see the PLA melting a little bit underneath the heat shrink. The heat shrink also has, it's that stuff that has the glue built into it. Okay, and then once it's like that, I like to just kind of give it a mush. I don't know if it's helping at all for water, but it seems kind of ambitious to get it to be watertight. I mean, things are never watertight, even when they seem like you can try your best to make things watertight, but you're better off most of the time just leaving a place for water to escape. I'm not doing that. If water gets in here, it's in there for good. But it, you know, it's a, I don't know. I don't know what the right answer is. There's no right answer. It'll die eventually. Just like it died once. It's now resurrected. Okay. And that is my complete over-engineered, overdone, completely unnecessary housing for my, but squirrel-proof. All right, and then I guess, before I can declare total success, I need to put it all in front of the camera. I keep forgetting to turn off the meter. That's why it's angry. Okay, so here you go. You got it all in front of you. And I'm going to plug it in. Oh. Ooh. Let me turn down the lights for mood and effect. Oh, look at that. It actually does look nice. I used warm white LEDs, and they look a lot like the incandescents that were in there before. The angle on them is very good. These are not as good as the, you can see the big brightness difference, but they're much better than the round top ones. The flat top scatter the light more. The other ones that I have where you don't have to nibble off the fringe, they have a convex lens and it sends even more light out the sides. And they're meant specifically for Christmas lights. So anyway, there we go. Now I can put all my Christmas lights away for the season, and they'll just work when they come out of the box, right? Next year. All right.